In this video we're going to look at what we call vector geometry, and the way I see it is a way of using existing information we've got about movements to work out others which are not known but we can deduce. So in my example I've got a trapezium, and the vector that takes us from O to A is called A, the vector that takes us from O to B is called B, and we're also told in this example that the vector that takes us from A to C is twice the vector that takes us from O to B. Now what I would do on these sorts of examples is draw on the diagram the information we know. So the movement from O to A is vector A, so let's mark that on. The vector that takes us from O to B is B. Now the first thing we're asked to work out is what the vector that takes us from A to C is. Well, A to C is twice the vector that takes us from O to B, and very simply the vector that takes us from O to B is B, O to B is B, so therefore A to C must be twice the vector B. Basically a movement in the same direction, in this case parallel, and it's twice the distance. Now the second one we're going to be asked to work out here is finding the vector that takes us from B to C, from B to C. So this notation here means starting at B, ending up at C. So we want to go from B to C, but we don't actually know what that is. Now I'm just going to put on the diagram the other thing we just found out. The vector that takes us from A to C is 2 lots of B. Right, so how do we get from B to C using information we know? Well, we can't go straight there, but what we're going to do is go along the lines we know. So we can go from B to O, so B to O, then from O to A, and then finally from A to C. So now, well, the vector that takes us from B to O, well, this time we're going to go back along this vector, which is currently called B, so the movement in the opposite direction, same distance, opposite direction, instead of being B, will be minus B. The vector that takes us from O to A is simply A, and finally from A to C, we worked that out earlier, that is 2 lots of B. So now, a bit like algebra, let's simplify this expression at the end. We've got minus B plus A plus 2B. Notice the vectors annotated with a line underneath. So we've got A, and then we've got minus B plus 2B. Well, it's the same as just having a single lot of B. So the vector that just takes us from B to C is A plus B. I'm going to continue this with look at another example where we've got a triangle OXY. The vector that takes us from O to X is going to be called vector X. The vector that takes us from O to Y is called vector Y. The 2 points here we've got P and Q. Well, P is the midpoint between O and X, and Q is the midpoint between X and Y. Now first thing we want to find is what the vector is that takes us from X to Y. Well, X to Y we don't know, so we've got to find a route there. So let's write this down. We could go from X to Y, and we can find a logical sort of way of getting there. We can go from X to O, because we know that vector. So X to O, and then from O to Y. So it's a long way around, but at least we know that the vectors for those paths. So the vector X to O is going in the opposite direction to the vector X, but it's going to be it's the same length, but just in the opposite direction. So in that case, that vector will be known as minus X, and the vector that takes us from O to Y is going to be plus Y. So our vector will be minus X plus Y, and let's just mark that on our diagram. Right, we're now going to continue, and we want to find the vector for the path Q to P. Remember, Q and P are midpoints. Now let's see what information we've got. Well, we don't know at the moment the direct route, so we're going to take a route we do know. Well, we know something about X to Y, so let's go from Q to x, and then from x to p. So we're going to use the information we've sort of built up to find this information. Now, the whole movement from x to y is minus x plus y, and that's going in this direction, but we want to go in the opposite direction to that, so it's going to be the opposite of minus x plus y. So we know it's going to be x minus y. That's if we were going all the way from y to x, but actually only making half that movement. So our vector will be half of x minus y. Right, we're now up at x, and we're now going to go from x to p. Again, we're going against the vector, so it's going to be a negative movement. And again, we're only going half the distance. So we'll be then taking away half of x. Now if we simplify all this, we've got half x minus half y minus half x. When we simplify all that, these two vectors cancel out, so our vector q to p will simply be minus half of y. So it's just a question of building up the logical steps and then plugging in the information you know and doing a bit of simplifying at the end.